Hey guys, TRM for Life here, and this is a Debunking D Marble, part 1. Now, D Marble recently did a test where he pointed a laser across Puget Sound to capture it on a camera from the other side to see that he could see the laser beam on the other side. A couple of big problems with this test. Now, first of all, his friend was standing at the water level, right? Well, you can see that the laser that he was using was clearly taller than his friend. So let's say his friend is 5 feet tall. Well, his laser tripod was likely about 4 feet tall. So now you have 9 feet over here that you've added to the height. And he says that his camera over here is at 3 feet. And there's also, not to mention, the camera that's in his hand, which was likely a foot or more taller than that, possibly 2 or 3 feet. So now, your observer over here is 6 feet tall, and your laser over here is 9 feet tall. 6 feet plus 9 feet equals 15 feet. So you've actually changed your viewing distance. Then, as at the very beginning, he's asking him to move the laser, because you can see the laser was pointed far above his head, and he asks him to point the laser downward. So now you've got something over here 9 feet high pointing downward to something that's 3 feet high. And we can see here, distance to horizon, 1.23 times the square root of the height of the observer. And these are just some basic breakdowns of the curve, you know, more or less based on distance. I don't know how accurate this is, but 1/8 of a mile, or I'm sorry, 8 inches per mile, which is 25.4 millimeters. An 1/8 mile would equal 1 inch of curve, right? So 660 feet, 1/8 mile, down to 1/64th, which would be 10.3 feet, which is 0.4 millimeters. I know I showed this in my previous video, why it's hard for you to see the curve, because 0.4 millimeters is about the thickness of a person's fingernail. At 10 feet, nobody's really going to be able to see that distance, and also the thickness of a laser beam is likely bigger than 0.4 millimeters, so you're not really going to be very accurate trying to use a laser for that. This is also some numbers from GitHub showing that 0.67 feet, you have a 1 mile horizon, 0.75 feet, which is 9 inches, 1.06, and this goes on here. Now, the main reason that I wanted to show 17 feet is because you have a 5 mile sight with 16 feet not visible. So, if we consider the fact that we don't know if the water was above or below sea level, or what their height is in relation to sea level, we have no comparison. So he's 3 feet tall, he's 9 feet high, pointing downwards, and you still see the laser beam at the horizon. So literally, he's managed to debunk himself, showing that the laser beam, that the tripod and his friend are both no longer visible at the other end, with him being 3 feet tall and us not knowing what the tide is relative to sea level.